We'll take a look at confidence and prediction intervals, both taken in the context of prediction, by first looking at this example of a scatter plot with regression line. This represents gray matter density in Facebook friends, where we can see from the description here of the background information, the gray matter density is calculated in areas of the brain associated with social perception and associative memory. So it's the social part of the brain. Looking at that density of the gray matter and converting it to a z-score. So if we look down here at our gray matter density scale, each of these numbers is a z-score, meaning that right here at 0 we have average density, and then we have, as we go up to 1.0, that would be one standard deviation above average, and as we go down to negative 1.0, that would be one standard deviation below average gray matter density for that part of the brain. We can see that the number of Facebook friends that a person has does seem to be positively associated with the gray matter density in the social part of the brain, which does lead us to believe that we've identified the correct part of the brain, right? People with higher density in this area tend to be more social, at least as measured by the number of Facebook friends. First, we're just going to estimate the average number of Facebook friends corresponding to a gray matter density score of 1.0 just by reading the graph. So starting here at 1.0, that is one standard deviation above average for density of gray matter in the social part of the brain, gets us to this part of the graph, which corresponds roughly to what looks like maybe 450 Facebook friends. So just taking a straight reading from the regression line, we get 450. Now, the meaning of this 450, for one thing, it's just an average. And for another thing, it is just based on a sample. So we're going to address both of those issues by getting into confidence and prediction intervals. The first kind of interval, which we would call a confidence interval, we get just by extending out from that 450 a little bit and saying, okay, what if we want to generalize from the sample to the population? We know that that would introduce some margin of error, and so generalizing from the sample to the population, we might get an interval that looks something like this. Of course, we know from our experience with confidence intervals that when we generalize from a sample to a population, it always introduces a margin of error that's just based on how much error we think is reasonable to expect just from having chosen our sample at random. So that generalizing to the population, this is what we have learned to call a confidence interval. Now, the other question we can start to ask is, okay, that still only addresses the mean. So after we've introduced that margin of error, we could say for a z-score of 1.0, we expect that the average number of Facebook friends is somewhere between, I don't know what values are exactly right, but on here I just drew a very rough interval that looks like it goes from maybe about 425 to 475. We'll get a better idea of what those actual numbers are soon. Now we can say, what about if we're interested in predicting what an individual's number of Facebook friends is likely to be? Well, if we're predicting for an individual, then we have lots of sources of variation. We have this individual way up here, we have this individual way down here. All of these individuals have pretty close to a gray matter density, one standard deviation above the mean, and we can see that that looks pretty widely spread out, so we would expect this interval to be a bit wider. So when we go to predicting for an individual, we're going to get something a bit wider. This is no longer just generalizing to the population. This is now also taking into account individual variation, and we are now predicting for an individual. So there's two different intervals that we're looking at here. A confidence interval and a prediction interval. Now the confidence interval is taken in the context of prediction, but the confidence interval applies to the mean. So the confidence interval we get just by generalizing from our sample to the population. So our mean mu instead of our mean x bar. We get a confidence interval for that. A prediction interval is a confidence interval that represents prediction for an individual, and this one has always got a larger margin of error. So the prediction interval, pi, has a larger margin of error than the confidence interval, because it needs to take into account not just how accurate our guess was, but also how much variation there is from one individual to the next. We could take a huge sample and get a really, really close estimate for the mean, but it's not going to bring in our margin of error on our prediction interval very much, because that still has to account for the natural variation from one individual to the next. So they always look like this relative to each other. If I mark a confidence interval, or let's start with just our predicted value, right? Our single point predicted value. It's going to be at the center. Around that we have a confidence interval, a CI, for the mean. And then around that, much bigger, or at least some amount bigger, we have what we call a PI for an individual. So our goals in this section are two things. One, always knowing that the CI is the smaller interval with the smaller margin of error than the PI, so that if we're looking at two intervals and we're asked which is which, we can tell. And two, to be able to interpret them just like we've been interpreting confidence intervals all along, making sure that we put in this careful distinction where a PI always describes an individual and a CI always describes a mean. We are not going to use software to get this output ourselves. We will just focus on answering questions for which software output is already provided. The reason for that is that StatKey doesn't support regression inference at all, so StatKey can't do these calculations. We don't really think it's worth taking on another whole software package just for a very small amount of regression material. So here we have some output that is provided from Minitab. So this right here is provided from Minitab, and it is prediction output for this particular model, and we can see that it is taken at a GM density value of 1.0, so this corresponds to that same value that we identified on the graph. we are given a 95% CI and a 95% PI, and we're going to interpret both of them. Now, first of all, notice that even if they weren't labeled as CI and PI, we would know which is which because this CI is more narrow and the PI is in fact much wider. In fact, even the just idea of an interval that I drew on the graph is probably not quite wide enough to capture this PI. It goes all the way from 100 to almost 800. So really, if I were to come back and correct this, it's more like all the way down here and all the way up here for my PI, and my CI is much, much narrower. So the confidence interval itself for the mean will get much more narrow if we have a larger sample, because we'll get a closer estimate, we'll get a better estimate. But that PI really kind of maxes out at some point, and it doesn't keep getting more narrow as we get a larger sample like the confidence interval for the mean does. Okay, so if we interpret both of these, let's start with the CI. That describes what we think the population mean is, where that is mean number of Facebook friends for a person with a gray matter density that is 1 standard deviation above the mean. We'll just say a gray matter density z-score of 1.0 because that's what our variable represents. All right, so I've gone ahead and written a sentence here. I did make an assumption about the population. I said all adults in the UK since this study was done in the UK, and I'm making some assumptions about how they took their sample, that maybe they took it in such a way that it's reasonable to make this. Actually, I might say all adults in the UK who are on Facebook. Seems reasonable to assume that we're only making a statement about people who are on Facebook. So the mean number of Facebook friends for this population, whatever we think is a reasonable population here, with a gray matter density score of z-score of 1.0 is between 368 and 530 friends. Now going on to interpreting the PI, it's going to be very similar to this. The main difference is that we need to make sure, we had to make sure we said mean in our previous interpretation. Here we need to make sure instead of mean we say an individual, and that we just reword as much as we need to for the sentence to still make sense. And we're going to use the other numbers. So here's an interpretation of our PI. So we have with 95% confidence an individual, so this is the most important difference between these two statements, on Facebook in the UK with a gray matter density z-score of 1.0 would be expected to have between 104 and 794 Facebook friends. Both of these interpretations do have to indicate that they refer to a gray matter density z-score of 1.0. That's in both of these. We need to say where we're making the prediction, right? We could see from our graph that this is not a statement about everybody, that we're not saying everybody has between 104 and 794 Facebook friends, but we would expect somebody who is in this region here of close to 1.0 for their gray matter density score to be in this interval that we've identified out here, going from around 100 up to 800. So again, we have predicting for an individual, that's the huge interval, just generalizing to the population, which is predicting for a mean, which is just a confidence interval for the mean, that's going to be a very small interval.